It's time to give our player a life. For this, I've created a health component. This is an actor component. Inside the same file, I've also declared a dynamic multicast delegate. Dynamic means that it can be used inside blueprints, and multicast means that it can have several bindings. This delegate is called f_on_health_changed. Inside the health component, I have a constructor, the declare delegate, a get current health function, a decrement health function, a begin play function, one expose starting health variable, and a private current health variable. In the CPP file, I set current health to starting health in the begin play function. Then I simply return the current health inside the getter function. In decrement health, I decrement health and broadcast our delegate each time health is changed, so we can react to this event in other places. Inside Asteroid Game Pawn, I simply added a forward declaration for the created component, then a getter function marked as ufunction, and a pointer to this component. In the CPP file, I included the header for this component, created the component in the constructor, and returned the pointer in the getter function. Then inside Asteroid Blueprint in the onComponent hit callback, I cast the other actor to the player. If the other actor is the player, I get the health component and call the decrement health function. Asteroids can damage us now. We also want to see information about our health in the game. For this we need some UI elements, so let's create them. UI in Unreal Engine is located in separate modules, so we need to include them in our build first to access them in the code. To do this, navigate to your project name.build.cs file, in my case it is called asteroidgame.build.cs, then add the required modules to private dependency modules name, such as UMG, Slate, and Slate Core. We'll be using these three modules. Creating C++ widgets is as simple as creating other C++ classes. Navigate to your asteroid game, click New C++ class, click All Classes here and search for User widget. Click Next, give it Player widget, put it inside UI folder and click Create Class. I cannot do it because I already created my Player widget class. Inside player widget, I have a forward declaration for horizontal box and for asteroid game pawn. Inside our widget class, I have native construct and native destruct functions. You can think of them as the equivalents of begin play and end play for widgets. Then I have a pointer to a horizontal box called player health box. Note that we use the bind widget meta tag. This is required so the widget system can find this element in the widget tree and assign it to our pointer. I'll show you this later when we work on the player widget asset. Next, I have a T subclass of hard widget. We need this because each health element will be its own widget. I also have a hard padding property, a fill player health box function, a ufunction called onPlayerHealthChanged, and finally a pointer to our player. In the CPP file, I cast the owning player pawn to our game pawn. We can do this because each user widget has an owning player controller, which is specified when the widget is created. This is the part of Unreal Engine's gameplay framework. Then I get the health component from our player, so we can bind our function to onHealthChanged. To bind it, I use addDynamic. After that, I call fillPlayerHealthBox. In native destruct, I unbind our function from onHealthChanged using removeDynamic. In fillPlayerHealthBox, I first use an ensure check to confirm that a valid hard widget has been specified. Then I clear player health box. After that, I iterate over the player's current health, and for each health point, I create a hard widget and add it to the player health box. Since Unreal Engine uses a slot system, when we add something to a horizontal box, it returns a horizontal box slot. This lets us apply padding. I add padding to all hard elements except the first one. In on player health changed, I check if the horizontal box has fewer children than the player's current health. Then I iterate over all of the heart icons, collapsing any heart whose index is greater than new health minus 1. For example, if we have 3 hearts and on-player health change is broadcasted with a new health value of 2, the heart with index 2 will be collapsed. I started by importing a hard texture. I'll leave a link in the description. For this texture, I set the texture group to UI, the compression settings to user interface, and the texture filter to nearest. We need these settings because we are using a pixelated texture. If we leave the defaults, it will look very blurry. We are ready to create our widget blueprints. For this I open blueprints folder and here I'm going to create a new folder called UI. Inside this folder, click on user interface and select a widget blueprint. In this opened window, select simple user widget because we won't be needing any additional logic in this widget and call it WBP underscore hard. This will be a simple widget that will represent our hard texture. So open this widget and here you will see a preview, palette where you can select elements and widget tree. For this we need only image. So drag it here and as you can see it looks a bit big for our case, but let's fix it. Here you can click on full screen and select the desired. Now it will be the size of this image. And you can click on this image and in details you will be able to change its parameters. But we need to select our t underscore hard here. Now it looks okay, but for our case it's a bit too small. So let's change it to 64 by 64. Yes, now it looks great and we can create our player widget and use this widget directly in player widget. Let's create a player widget now. For this, click on user interface and select widget blueprint again. But this time this widget needs to be inherited from our C++ class. So type player widget here, select it and call it WBP player widget. Now when you open it, you can press compile, but you will see an error. This happens because this widget didn't find the required horizontal box. So for this we need to open panels and select horizontal box. And this box should have exactly the same name as you type in the code. So in my case it is player health box. So let's copy it and rename it to this value. And now when we press compile, we don't see any problems and errors. So as you can see now, this is a very flexible way of reference something in the widget tree. So we can drop an element, give it meta tag with bind widget, and then we can access this element in the code, which is very convenient. That's the primary use case of this bind widget. So right now we actually need to wrap it inside an overlay. So let's briefly fix it. Select an overlay here. Overlay is a simple panel that can have multiple childrens. And this time we need actually align our horizontal box properly. So select bottom alignment and we can actually wrap it with, no, we can actually just simply set padding here, that would be fine. Select 10 or even maybe 20, yeah, 20 would be ideal. And as a final step, you can click on graph and select player hard widget class here. Okay, great. Now when we create this widget, this horizontal box will be populated with all our hard widgets. We are going to create our player widget inside player blueprint. For this, open player blueprint. We can delete those nodes and type create widget. Connect this to begin play, type get player controller, connect this one here, and as a class select our player widget. Then drag here this pin and type add to viewport. Okay, now our widget should be created. Now we can press play, and as you can see we have 3 hearts here. Nice. Now we can also click on our health component, set value, for example, to 6. And now we should have 6 hearts. Yeah, great, everything seems to be working fine.